Number 7, we want to solve the equation. So we have absolute value of x squared minus 64 is equal to 0. So in this case, 0 is a neutral number. There's no such thing as a negative or positive 0. So we're only going to have to solve this problem once. But hopefully you notice this x squared term means you'll have 2 answers when we factor this out. So I'm going to drop the absolute value and just say x squared minus 64 equals 0. And we can solve this by adding 64 to both sides. And then we can take the square root of both sides. So when we take the square root of x, that just leaves us with x. When we take the square root of this number 64, we get positive or negative 8. So we get 2 possible answers, positive 8 or negative 8. Alright, so with number 8, there will be many different variations of this type problem. So let me make a note. You might have absolute value of x, and then you will have some situation that have greater than some number, a, and then you might have the scenario where you have absolute value of x, and then it says less than this number a. Okay, this is how this works. When you evaluate this absolute value, you will write your expression, whatever you have, x greater than a, just like it says, and then you have or another side, you have x less than a. You have to flip your inequality sign when you change this sign. So you have this and this, you solve it, and then these will be your 2 solutions. Alright. When you have less than, okay, you will do the same, something similar. You have x less than a, and then and is the number here, or and is the word here. You will have x is greater than negative a. When we compound or put these 2 terms together, sorry, it's kind of running off. See if I can get all that on there. Okay, when we compound and put these 2 together, and I put x on the left-hand side, the end result will be a negative a, or whatever you have when you solve it, is less than. So we're just flipping this x, and then we're just compounding and bringing this one down. That's the same x less than a. So this scenario, what I need you to see, this scenario yields to this end result. Now, it could be brackets if it was underlined, or if it's not, it'll be parentheses. And then this result, okay, will yield a problem that has just 2-sided. All right. So on a number line, what this would look like, let's just say 0 is here. You have a positive a value, and you will have a negative a value. And when you compare x to a, it's going to the right. So you'll be shading this way. And from your negative, you will be shading to the left, because your variable on the left, this inequality points you in that direction. And then from this scenario, when absolute value is less than a, you will have a I don't know, I can't remember the exact term, but you'll have your a, your negative a here, and then your positive a here. You have the compound. Both of these are called compound, but this one will be joined in the middle, and it just wants the middle part of both of them, and this one is going to be looking for the outsides. So you have to be mindful. There's different scenarios. I don't know which type you have, but for me, I have this first type. So my final answer will look like this. So we do want to solve it and graph it. So if yours looks like this, it will be different than mine. You will have this scenario. But the problem process is going to be the same. So number 8, absolute value of 5x greater than 20. So I will have 5x greater than 20. So notice how it's positive. That's how we know we can solve it. And then or 5x is less than negative 20. Change the sign, flip the symbol. Divide by 5, one-step inequality. We get x is greater than 4, or divide by 5 over here, and we get x is less than negative 4. So these will be our two solutions. And then when we graph this on the number line, I put 0 in the middle. Here's negative 4 on the left, positive 4 on the right, and positive 4 is going to the right, so I will be graphing this way. And then negative 4 on the left is pointing to the left, so I will be graphing this way. Okay, so that's our solution. So first, we need to go to negative infinity, comma, negative 4. Now when we say or, we also use this union symbol. I don't know if this program will allow you to separate these two with a comma, but I'm doing this in interval notation. So this left side, I'm doing, this is negative infinity. So I'm doing, can I squeeze it in down here? Negative infinity to negative 4 to represent this. And then there's a break in the number line, and then we connect it. This is like our connector, union, or the or symbol. And then we go over here, positive 4 to positive infinity, because that's where that's going. So this is how what I'm writing in now. So I don't think I explained that beforehand. And then we have 4 to infinity. Okay, so I guess we want to say, okay, so there are finite. Okay, so this is infinite solution. So I just put it in the wrong box. We want option B, same thing. We're going to type it that interval notation because there's an infinite number of solutions since it encompasses that whole interval. Negative infinity to negative 4. Just input in the wrong one. Union 4 to infinity. So just be careful to read what it's saying. So it would be like if there was just like one number, like 5 and 6, I would use this. But there's infinite solutions in between here, so we need B. Now we want to graph it. So the graph is going to match this one. These are kind of small. So it's not the whole number line, not A, not just one point, not the whole number line. B is in between, and we have the outsides. So looks like G is going to be what we need, so that would be negative 5, so that has to be 4. So G is going to be the number line that matches what we want.